Okay guys, see this paper I gave you the other day before you left? The one that says problems on the front side, and on the back side it says significant figures practice, okay? If you notice, part one was determine how many sig figs there are in each of the following. We're going to go through those real quick, and then right below it, part two and part three we're going to look at. Those are scientific notation ones, okay? So what I want to do is I want to go through those just to make sure that we know part one real quick again. Kind of a repeat though. All right, part one. There were 5 of those. Okay? Part 1 says how many significant figures are in this number? Well, 195.01. Well, that should be obvious, isn't it? There's 4 of them, and that one captive 0, so there should be 5 captive zeros count. Number 2, 0.00010. Well, leading zeros never count. Trailing zeros count if there's a decimal. So you should have only 2 of those. Okay? The next one, 998,870. Well, obviously these 5 count. That last one, that 0, that trailing 0, does it count? If and only if there was a decimal. There is no decimal, so the number is 5. That 0 does not count. This one right here, 4, 1.00 times 10 to the 4. You only look at this thing right here. Well, there's 3 numbers there. Those zeros are trailing, and there is a decimal, so they count. So 3. And then number 5, 5,000. 5.0. The 5s count. These 2 zeros count because they are trapped. They're captive, right? This 0 counts because there's a decimal, because it's a trailing 0. So that gives us 5 as well. Okay? So I hope that's pretty straightforward with part 1 of the Sig Figs practice paper. All right. Now part 2. Is converting each of the following to scientific notation. Alright, so number 6, 0.00785. Alright, how are we going to solve that? We're going to convert it to scientific notation. Well, we take where our decimal point is, and we got to move it to one space where there's only one number to the left. 1, 2, 3. So I'll put this number 7.85 times 10. And how many places did we move our decimal? Well, obviously 3. But you'll notice, this number is less than 1. So my decimal, or my exponent should be a negative number because this number is less than 1. So that's going to make it -3. Okay? Now, the next one says 1,007. Okay? So what do we do? Well, first off, there is no decimal, so we put a decimal there. Then we move it to where there's only one number to the left of the decimal. 1, 2, 3. So then I put my M here, 1.007. Those count, don't they? Because they're captive zeros anyway. All right. Times 10 to the what power? Well, that would be to the 3rd power. And it's positive because my number is greater than 1. 1,007 is definitely greater than 1, isn't it? Okay. Number 8. 15,310.1. Again, same thing. We're going to move our decimal to where there's only one number to the left. 1, 2, 3, 4. So I go 1.53101 times 10, and again that 0 still counts because it's a captive number. And how many places did we move it? 4, right? And since this number is greater than 1, we're going to put that as a positive. Okay? All right, number 9. That's right. No. I'm sorry. That's what I get for not looking like I should. 35006700, right? Yes. 35,006,700. Is that right? Yes. 35,006,700. Well, the first thing we got to do again, there is no decimal. So we have to put the decimal. And we're going to move it however many places that we need to. 1, 2, 3, 4, 5, 6, 7. Okay? 7 places. So we're going to write the number 3.50067. Now, why did I write these last 2 zeros here? Well, they're trailing, aren't they? Was there a decimal there in the beginning? No, there wasn't. So they're not significant, so I don't have to put them. Now, I can just go times 10 to how many places? How many places did I move it? 7? 1, 2, 3, 4, 5, 6, 7. Since this is definitely bigger than 1, we can put that. So that's all I have to do there. And then number 10. 0.03170. All right, decimal's there, and I got to move it so that it equals to 1 to the left. So I go 1, 2. So I put 3.1700. Now again, why did I put those there? That's supposed to be a decimal point, sorry. Why did I put those there? Again, there is a decimal. Trailing zeros count if there is a decimal. So I have to put them there. Times 10 to the what? Well, less than 1, right? So I moved it 2 places. And it's less than 1, so I have to put a negative 2. Okay? So, I hope this helps you see how to convert to scientific notation. Okay? Now again, if you have any questions, don't forget to ask me. Alright, the last one we're going to do is part 3. Now we're going to go the reverse of what we just did here. We're going to go from scientific notation to normal, standard numbers, standard notation. Okay? So that's part 3. We're going to do it in reverse. That should be 11 through 15? Yes. Okay. So number 11 says 1.37 times 10 to the negative third. Okay, first off, guys, this exponent is negative. So the actual number is going to be less than 1. Okay? So if this number is a negative exponent here, this number has to be smaller than 1. So which way am I going to have to move my decimal? Right or left? Well, if I move it to the right, that number is going to be bigger than 1, isn't it? But if I move it to the left, it's going to be less than 1, isn't it? So I'm going to move it, and I'm going to do this. and I'm going to move it. 1, 2, 3. And I'm going to have zeros there. So I'm going to put the number 0.00137. Now, why did I put a 0 here? The reason I put that 0 there is to let me know that that is an actual decimal, that it is a true decimal, okay? That's where the decimal point is at, and not an accidental, marking. So what if I accidentally did that, and I didn't mean to? Which one would it be? Well, if you put that 0 there before that one, I'll know that that one is, and that one's just a mistake, right? Because sometimes we do that. We're writing, and then all of a sudden we boink, and we accidentally mark something we didn't mean to, right? That's why we do that, so that we'll know for sure that that is the actual decimal point. Okay? So let's look at 12. 2.9070 times 10 to the 6th. Well, here's the thing, guys. 6 is a big number. There's a positive exponent, right? Which means this is going to be a very big number. 1, 2, 3, 4, 5, 6. I'm going to put 2 zeros here. That's a big number, isn't it? So I'm going to put the actual number 2907000. 2,907,000. Okay? Pretty straightforward, huh? I would think so. Oh, actually, you don't do that. I didn't apologize. In actuality, there is technically no decimal there. Okay? Otherwise, those zeros would have already been there. Okay? 13. 7.500 times 10 to the 3rd power. Big, positive exponent. This means it's going to be a big number. So watch this. I'm going to move it to the right. 1, 2, 3. 7,500. And that one should be there because we have those zeros there already. They're significant, right? So 7,500 decimal. Again, fairly straightforward stuff. 14. 4.301 times 10 to the -5th. Well, the -5 means that this number is going to be less than 1. So I got to move my decimal not to the right, but to the left. So I'm going to do this. 1, 2, 3, 4, 5. I got to have 1, 2, 3, 4 more zeros. So I go 0.00004301. That is number 14. That's how you convert from scientific to standard. Okay. And 15. 9.000 times 10 to the 2nd. All right, what is that one? Well, 10 to the 2nd is a positive exponent, so I've got to move this decimal. It has to be greater than 1, so I got to move it 2 spots, right? 1, 2. So, my answer, 900.0. Okay? And again, that 0 is significant because we had it up here, so I have to put it in my answer. Okay? All right, that's how we convert from one to the other, either to sig figs, or scientific notation, SciNot, or from scientific notation, okay? Again, if you're having any questions with these things, do not hesitate to email me, okay? And in worst case scenario, you know how to get in contact with me, do it, okay? Because if you don't, you're going to get left behind starting on Monday, okay? All right, so if questions, let me know.